On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to look at a related rates problem that deals with a ladder, and this is example 2. A ladder that is 20 feet long is sliding down a vertical wall at a rate of 2 feet per second. At what rate is the angle between the base of the ladder and the ground changing when the base of the ladder is 12 feet from the building? Example 1 has the same type of ladder, the same length, is sliding down the wall at the same rate. However, in example 1, we determined the rate at which the base of the ladder was sliding away from the wall. We still have a very similar problem here though. So I've drawn a right triangle here. This is very similar to the triangle we did in example 1. Now we want to talk about theta because it says at what rate is the angle between the base of the ladder and the ground, that's this angle theta we have here, at what rate is it changing when the base of the ladder is 12 feet from the building? Now there's a couple of ways you can do this, but whenever we talk about rates of change with an angle, we have to involve trig, some type of trigonometry here. And since I know this rate of change over here, and as a matter of fact we did find the rate of change of this side here, regardless, since I know this one, I want to use side A somehow or another, and I'm going to use side C as well because the ladder's length is never going to change. dc dt, the rate of change of the length of the ladder with respect to time, is going to be equal to 0. So that's going to be very helpful since the 20-foot ladder never changes its length. If I want to use side A and side C, I'm going to use the sine ratio. The sine of theta is equal to the opposite side over the hypotenuse. Now, some of these things are going to change. The angle is going to change as this ladder slides down the wall. This angle is going to get smaller, which implies we have a negative rate of change here. The A is going to change. The height that the top of the ladder is from the ground, that's going to change, but this C remains the same. It's always going to be 20 feet. So I'm going to write down the sine of theta is equal to A over 20. Now let's differentiate so that we can figure out what we're trying to find here. We're trying to find the rate of change of theta. Well, the derivative of sine of theta is cosine of theta. But since we are differentiating with respect to time, let's tack on our d theta dt is equal to the derivative of a over 20 is 1/20th because the derivative of a over 20 is 1 over 20. But let's tack on our dA dt as well. From here, it's just a matter of plugging things in correctly and making sure we get our cosine of theta correct. We're trying to find d theta dt. That's going to be the rate of change of the angle as the top of the ladder is sliding down. dA dt, we know that's -2 right there. So let's find the cosine of theta. So here's that right triangle again, and if we want to find the cosine of theta, we have to take the adjacent side over the hypotenuse. Well, what we know at a certain instance is that the base of the ladder is 12 feet from the building. That's going to be this adjacent side to theta. Our hypotenuse is going to be 20 because that never changes. That is going to be our cosine of theta, 12 over 20, and we can reduce this down to 3/5. d theta dt is equal to 1/20th times dA dt, which is the -2 feet per second. Now to get d theta dt by itself, we can multiply both sides by the reciprocal of 3/5, which is 5/3. And when we do that, the fractions cancel out. We have d theta dt is equal to the product of all of these numbers. So taking the -2 times the 5, that's going to be a -10 over 20. That's -1/2 times this third, that's -1/6. And by default, this will be radians per second. Notice we have a negative rate of change for this angle, and that makes sense because as the top of this ladder goes down, this angle here is going to be getting smaller. And there you have it, example 2 of a related rates problem that deals with finding the rate of change of an angle. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.